a very rich and forested area. I would like to show you, it's not from CSAT, it's from recent data, what is possible. For example, this is more or less the same area investigated by NASA archaeologists in the 80s by Thomas Farr and Diane Evans and so on. Just to show you the potentiality of radar data, this is the desert, and this is what you can see using the radar data. So this is optical data from Google Earth. If you process radar data, you can see what is under the sand. Of course, I don't like to stress, of course, on the methodological approach, but we can discuss later. In the case of radar, it's important to have a time series so we can combine these different data and to extract some information. This is another example. This is a time series, and this is what you can see from Google Earth, and that, of course, what is present under sand. Another example, this is from Sabrata in Libya. In this case, I would like just to show you some ruins. This is, of course, a Roman area, and you can see some remains under the sand again. Sometimes it's also possible to use Pleiades, a passive data, optical data. In this case, it's quite nice because we can have similar information. Because you have to imagine that what we can extract is not only linked to the remains, the presence of remains, but is also linked to the superficial condition, the humidity, the moisture, and so on. Well, this was the starting. But now we have many investigations based on the use of satellite data, just because we have the possibility to have from satellite very high resolution as from the area. And also in the case of the publication in the last year, we have an increase, just because we have also the data. This is just some special issue. I had the pleasure to coordinate as a guest editor, and we are, of course, working on this. Will be closed at the end of this year. And also a book focused on the, let me say, methodology and also application. So the use of remote sensing is very interesting for discovery. We can improve the knowledge, and we can, of course, monitoring several types of danger. The problem is the processing, because of course you have to imagine that we, in the case of archaeology, we are searching for very subtle signals, because we are interested in generally in remains, buried remains, and you can imagine that it's not so easy to detect these buried remains. But it's important to have the possibility to manipulate the data, and in this way it's possible to enhance these spatial and spectral anomalies. So the approach we propose is, of course, linked to the modeling, because it's important to know what is our target, what is the main characteristic we are interested in, so we can call expert knowledge, and then we can have the possibility to set up some data processing. I would like just to show you what is the signal we are searching for. This is, for example, the spectral band relating to quick bird, but is generally these wavelengths are present in all optical data. It's just a matter of spatial resolution. In this case, if we think about quick bird, we have a pixel less than 1 meter. And this is, for example, our target. We are searching for buried remains, and we can observe not exactly the buried remains, but some subtle signals which are linked to the presence of these buried remains. In the presence of crops, and we can observe that the vegetation is less green, for example, and we can be able to appreciate this discontinuity. And again, this is in the case of the presence of a wall, but if we have a pixel ditch, we have exactly the contrary. So we are searching from some anomaly linked to this behavior in the presence of vegetation, but if we have bare soil, we can have again some different subtle anomaly, as in the case, for example, of moisture. If we have greater or less moisture, it's possible to appreciate the presence of anomaly. It's a pity this is completely, but I have other slide just to show you. This is in the south of Italy, Metaponto. Metaponto is a Greek Roman town, was the place of Pythagoras, so it's quite important from this point of view. And we investigated, I put here, but I can show better in the next slide, the presence of some subtle marks linked to, in this case, it's really important also the acquisition time, because if we think about crop marks, you have to think that this means that we have crops, so the period is just in a specific period of the year, I mean 10 days, 7 days. That was one of the first results of our investigation, was that it's also possible to detect this anomaly during, for example, summer. This is because we can have, due to the presence of moisture, nutrients and so on, we can have also the possibility to appreciate the presence of this anomaly. It's not so clear, but for example, this is the anomaly I speak about. In this case, we are speaking about the land division dating back to the Greek period. In this case, this land division was a drainage channels, because of course the landscape was completely modified by Greek. But as I told you, I would like to go from one place to another, so we have the possibility, this is for example the enhancement, as you can see. It's not evident from this, but this is the RGB composition of red, green and blue channel. And this is the map we obtained after this analysis. But if we change from crop to desert, you can easily imagine that it's completely we have a different situation. This is some pyramids in Kawachi, close to Nazca, and as you can see, no vegetation here, so we are only sand. And in this case, we were interested in evaluating if the use of optical data can be useful in this environmental, and with these marks. You can see here, another important issue is that in this case we have only adobe, is not bricks or stones. Adobe is earth, so you can imagine that the difference, the contrast is very, very subtle. But again, we can observe this area. This is a, let me say, a walls made in adobe. It is absolutely evident from satellite because of the color. So it's a different way. But again, it's really important the bird view, which enables us to identify the remains from Nazca. But it's really important to think about the integration, not only using satellite, but also using, for example, geomagnetic prospection, also because we can have a different scale. We can have, let me say, some anomaly, but before the excavation, we go in situ with the geomagnetic and, of course, georadar, for example, just because it's very important to use non-invasive technology. After this is, for example, Ventaron in North Peru. We detected some anomaly from satellite. We go in situ, we have some geomagnetic and georadar prospection, we detect some anomaly, and this is the results of the excavation. So we can say that our approach is to have a real-time excavation, because we have the geophysics prospection and more or less very close in the time also the excavation, which can confirm or not the presence of remains. In this case, we are very lucky. Then, another example is relating the monitoring, because we told relating the discovery but also the monitoring. In this case, it's very important. You can see here, these are remains of looting, clandestine excavation. And of course, you can imagine that this is, for example, a result of a clandestine excavation, the Rusting. It is the same situation, for example, in Iraq, or if we have a war conflict, everywhere we can have this situation. This is for give you the scale of the phenomena that is not only in South Peru but also in Italy everywhere. So, satellite can provide, of course, satellite cannot provide any solution, but can provide some useful information to support the monitoring and also to provide some, let me say, some information for the solution. And in this case, we can, for example, use different approach. In this case, is the well-known LISA to identify this hole relating to clandestine excavation. And we can, of course, have different results applying different index, but we can have also interesting results using web analysis. Of course, another branch of our activity is to compare the results of different methodology and to evaluate, using, of course, in situ analysis, to evaluate the accuracy of these. I would like just to show you let me say, the added value of satellite. This is, for example, the panchromatic, and this is what we obtained applying LISA approach. Again, close to the Nazca, where we have the famous Nazca line. Another situation is in the north of Peru, is Ventaron. Again, we applied, in this case, again, LISA. But after the application of LISA, we applied also some classification, because it's very important to search for automatic or semi-automatic data analysis, just because, as we told at the beginning, we have a huge amount of data, so we can process this huge amount of data if we are able to set automatic or semi-automatic data processing. And this is the results from, again, Ventaron, and this is the results from the detection of clandestine excavation. And this is the results of the unsupervised classification. This is the final maps. You can see all this area is completely interested by clandestine excavation by looters. And another approach, because when you have some clandestine excavation, you can have also buried structure. We can consider this area as interesting test sites, and we go there to check, using, again, in this case, a georadar, some buried remains, because, of course, looters can take the some, let me say, some artifacts, but of course settlements are still there for the moment. Another example is the monitoring of Nazca line. This is a photo of Nazca line. Maybe it's not so clear, but this is another very famous Nazca line. And I would like to show you what is evident. When you are in situ, it's not so easy to identify. We have different Nazca lines. There are the Nazca line, UNESCO heritage. It is not possible to go in situ because it's forbidden completely. But of course, there are other Nazca lines. We are working on Hanno Nazca line. But when you are in situ, it's not easy to identify these traces, and this can be easily identified using, again, satellite or, of course, also a photo. But it's a pity because it's not easy to maybe it's not evident, but this is a PIAT data, has been processed, filtered, and in this case it's possible to identify, for example, some traces of the human impact, because we can have also some motorway, and using this approach we can have also the possibility to date this line, because Nazca line has made by adding or subtracting material, so it's not easy to date. But if we have an overview, we can have also the possibility to establish some rough dating of them. This is the same image and it's more clear. You have a mixture, because Nazca line was made during more or less 1000, so 10 centuries, very long period. Another application, quite from my point of view, very interesting, is the detection of lost aqueducts. In this case, in Nazca, they are called puquios. Of course, this is a very important topic, because generally the race of some civilization, considering also Roman or other Maya, is anytime linked to the availability of water and to the capability of civilization to retrieve water. This is what is generally called pukyos. This is wells, horizontal wells, and these were built during the Nazca time. And as you can imagine, if we are able to identify these lost pukyos, we can be also able to detect unknown sites, because when you have water, a water retrieval, of course, you can have the presence of human settlements. And again, the possibility of satellite is that you can monitor a very huge area. This is a very huge area. We can have the possibility to use also DTM, because of course we are speaking about different type of data. This is a DTM obtained from Aster, but it's really important, of course, for this type of investigation, the analysis of the digital terrain model for the geomorphological characterization and not only. What is possible? This is, for example, the map relating to the river. It's very important to consider that in this case we have some permanent, some parts which are permanent, some parts which are dry, and some other parts which are subsurface due to specific geomorphological condition. So this is the map, this is what we obtained from satellite. So from satellite we can have also the possibility to have this type of information, and it's only possible from satellite or again ILMB. We can have the possibility, using a combination of different spectral data, to combine and to monitor also the water availability from one year to another or from one season to another. And our project was not only focused on the archaeology, but also on the possibility to reuse the pukyos, so on the possibility to have a social impact, because we are in Nazca desert and it's really important the water availability at the Nazca time, but also today. And what we can do for this type of investigation is multi-temporal data analysis, and after this multi-temporal data analysis we were able to identify some anomaly, moisture anomaly, to go, for example, in this case the results were obtained using raster data, then we check these results from one scale to another using quickbird data and again with the geophysical prospection, and we are able to identify these lost pukyos. We have many, so at the end we go in situ to check and of course to verify what was detected using satellite data. And this is, for example, the, let me say, dolce of pukyos, but in some cases you can find just something like this. I would like to show you another example. We are again in Peru, close to Lima. It's a beautiful area, it's Pachacamac. This is another UNESCO heritage, very important for the walls of America because characterized by a long human frequentation, starting from 3 or 4 millennia before Christ. In that case we have a different, of course, dating, and until the Spanish. Again, in this case it's also important because generally we have different building material. We can have also stone, but in this case depends on the availability of material. We have again adobe. We detected using player data some anomalies. This was just some prospection we made at the end of the last year in December. This is the map of the anomaly obtained using the georadar. And it was very nice because we identified some of linear anomaly. This is what was verified by the archaeologists by the excavation conducted since February to more or less these days. This is another example in Bolivia, Tiwanaku. This was the capital of Tiwanaku civilization. You can see this is the satellite, and you can see here what we obtained for geomagnetic prospection. But another important consideration is that when we are here using the geomagnetic prospection actual GPR, we can investigate very small area compared to satellite. And for this area, we were able to identify using, again, raster and quickbird data, some anomaly. And this was very important. You can see here some anomaly. This is quite huge. This is the sphere, so the pixel size is 90 meter. But were enough to identify these drainage channel. And of course, it's really important the interpretation of these results, because this drainage channel suggests that we have, this is the most important part of the archaeological area, but here we have a second part. It was as important as the first, just because of these drainage channels. Of course, again, we are in situ. We were in Bolivia just this June for additional investigation, and this additional investigation confirmed this. Another very nice application is relating to desert area. We are interested in this case on the Silk Road from not exactly Beijing, because Beijing was a quite, let me say, one of the last capital of the Chinese dynasty. Before Beijing, we had different capitals in different areas. This is one close to Zhengzhou. So in this case, we can have the possibility to identify some lost traces of the Silk Road. I would like just to show you, flying from China to Turkey, some other application. We are close to Hierapolis, another beautiful UNESCO site. And Hierapolis is characterized by a number of rural settlements, Roman villa. I think that is really interesting to show you this photo, because we can have these, for example, from satellite data, but if you are in situ, you can find this. This suggests another very important application of remote sensing, because we can have information from in situ survey that actually this is very important from the archaeological point of view, but we cannot have any information relating where we can excavate it to find the settlements. If you see here, it's quite easy. From this to this. So this is, let me say, knowledge improvement. We know that is important, but we can provide additional information because the excavation are very costly and time consuming. So it's important to provide detailed information relating to the sites. And this is another application in south of Italy. In this case, the church was one of the first of Giorgio da Fiore, medieval time, and the topic was, we are interested in this area, but can be useful to go directly with excavation or not. So we use, again, the satellite data, we process the data, we find just these, and again, we go in this area with the geomagnetic prospection, and at the end, the results was this is a gate, ancient gates, but only gates. So the archaeologists, in this case, decided that was not the case to excavate, so was very important. And we use the satellite data for virtual reconstruction of the medieval landscape with my colleague Gabriele from CNR Institute. I would like just to show you some other application using LiDAR. LiDAR is a completely different technology, is active, and it's really important because LiDAR is able to capture remains also under the vegetation. This is the most important, let me say, added value of LiDAR. We can have vegetation, we can filter out the vegetation and find some anomaly. This is, of course, the capability. We can have in this case is LiDAR, is similar to radar, but the signal is able to go and to provide, for example, the vegetation and the traces under the vegetation. We had a very nice case study in south of Italy. This is EFC. We go first using satellite data, identify the castle, the medieval village, and then we go using LiDAR. This is the results of LiDAR. You can see very detailed because LiDAR is able to penetrate the vegetation. Again, we have the possibility to extract information relating to single building, even in the presence of vegetation, and we can also manipulate the data in order to enhance using different approach, principal component analysis, so we can use convexity or other methodology. But it's very important, for example, that we can have this information. In this case, it's useless to excavate because the excavation is very costly and sometimes it's not possible. In Italy, we have more or less the whole peninsula covered by archaeological sites, so it's not possible to excavate everywhere, but it's a way to digital excavation. And also for the monitoring, you can see we have here a landslide. We can say that is a paleo landslide. We can extract all the information we need, processing the data. And again, you can see here. One important application we made was not only for, it was a serious game, was not only for the research, but also for the educational, because in this case, we made a, let me say, a serious game for different, from pupils to students, to explain in a very simple way the different remote sensing tools as a young archaeologist. And at the end, thanks to the collaboration of my colleague Francesco Gabellone, we were able to reconstruct these sites. This is the first settlements in wood, and we had also other settlements in, of course, in stone. And it's quite important because we can have the possibility to process DTM not only from LiDAR, because it's really expensive, but we can also process DTM for the world region, and we can have the possibility to identify similar settlements. This is the typical mountain bailey at the time of one more or less late medieval time. This is the puzzle, again, is a serious game. In this case, this will be installed in the museum, so the young pupil will have the possibility to have this piece of information and to put together in order to rebuild the village. This is a digital, let me say, excavation. I would like just to show you what is now, we can of course enhance and process using different methodology, but using LiDAR we can have also the possibility to monitor the illegal excavation also in Italy. This is what we have, for example, close to Viterbo in Etruscan sites. We have looted tombs, clandestine excavation. We have the vegetation. By using LiDAR we can have also the possibility to extract this information. Of course, when we speak about the integration, LiDAR can provide this type of information. Using radar, we can have the possibility to monitoring landslide or displacement. This is the elaboration made by Cosmos Connect, Italian radar, and you can see the different areas identified and some movements. Generally, these movements are linked to the presence of water, but of course can be very useful because in some cases this is really important to monitor the stability of this very important area. I would like just to show you one of the last examples made by drone, because we can have very expensive technology as a LiDAR, but sometimes we need to have less expensive or very low cost technology, as in the case of drone. And what we did was the acquisition of a different photo from very cheap drone, and we reconstruct the DTM. This is the same case I showed you before, yes. Again, this is the, let me say, the castle and the medieval. Of course, using the drone, but not only the drone, using just a photo, we can have the possibility to reconstruct in a very speedy way, expeditive way, some, for example, in this case is a church, and of course the integration of this is another example, but I would like to go a little bit fast. The most important from my, let me say, experience is that it's really important to exploit as much as possible the available data. It's really important to, of course, in the case of archaeology, we need to have very detailed information, but at the same time, it's really important to set up improved data processing, because we can have some information, but we can do it better if the data processing and the model are well suited. And of course, the integration is, from my point of view, the next step, real integration, because we need to use the best from each different technology. Just to go quite fast to the final remarks, we have very nice data, we have very detailed information, but it's really important that we need to go in the direction of interaction between the archaeologists, the specialists, and the remote sensing, because it's very important to achieve the, let me say, the contamination, the so-called contamination, because each of us has some expertise, but it's not enough to achieve the best goal. So from my side, that's all, and I wait for your question. Thank you.
Thank you, Rosa, for this very stimulating presentation. Question? She's coming.
Yes, first congratulations for your very nice talk. Since the very beginning, I was thinking that now the drone technology has made such an advance that it can easily take over all kinds of satellite observation in terms of moment, of course, in terms of flexibility, control, iteration. Can you comment what is the evolution of your discipline?
Actually, it depends, of course, on the needs, because there are a huge, let me say, amount of drone from very, very cheap to very, very costly drone. So if you need very detailed information, as in the case of LiDAR, drone is not enough. If you need a perspectral, drone is quite costly, because we have to feel that sometimes we can have some picture, very nice picture, as in the case I show you for Monte ICCSA, very cheap and very fast. But in the case of additional information, we can also use satellite data, because at the end satellite data are sometimes available from archive, and in the case of data available from archive are quite cheap, so it depends. And sometimes in some area, as in Turkey, or where you have some conflicts, Iraq, it's not possible to fly anymore. In that case, satellite is only way. And also, in other cases, I show, for example, Ventaron, Peru, the size is so huge that in that case you need a very powerful drone, and let me say that at the end you have to consider benefits and costs. So it depends on the area, depends on the sites, depends on the knowledge you need, and it's not easy to say this technology is what we need for this site, because at the end the integration from my point of view is the best. But of course sometimes we don't need, so depends on if it's just a preliminary study, or if you need to provide some information to archaeologists for excavation. In that case you need very detailed information. I don't know if more or less I provide some.
No, but I mean, there are so many monitoring these days, like drone and all, you can do everything.
There is another problem with the drone. Of course, it's not inside this presentation, but if you use a drone inside, indoor, for also heritage, some church is perfect. But if you are outside, you have to consider that the drone is, let me say, maybe it's not any weather, because if the wind, it's quite complex to have a very nice photo. You have a very nice Japanese technology, they are able to readjust all the vibration, but again, the problem is the cost. And it's linked to what you have to do, what is the budget, and so on.
So thank you very much for a very interesting presentation. And I have two questions about a couple of related problems that we're facing in our GIS lab when we're working with the data. So one is the issue of missing data. So sometimes, as you mentioned in your previous answer, then there are some areas that you cannot get data using one or other or number of technologies. So they can be covered by, there might be no satellite coverage, there might be some security objects that are protected specifically in the US, and LiDAR data or satellite data might not be available. And the kind of related question is, do you use or employ? So first of all, how data integration can help in this case, in your opinion? And second, do you use or employ some certain specific tools? For instance, if we're looking at archaeology, and if archaeologists found some, pieces of some old building or ancient building or some artifact, then maybe not all the pieces are available. Like, I don't know if you came across any issue of trying to reconstruct this information, but taking into account missing data.
Thank you for that question. Actually, the data integration is just to, to cope with the data missing. Because I was quite fast because we have no time to discuss it. But if you think about the radar can have very nice application, but sometimes the radar cannot see some slope, so in that case you cannot use. And also in the case of LiDAR. So in that case it's really important that the integration using, for example, ground LiDAR and aerial LiDAR. So generally, when we have sites, we try to apply the best technology available, the best and available at low cost. This is, of course, what is generally our approach. Also in the case of Turkey, we work with different equipment, so it's really important from our research project. When we are in China, we work with the Chinese archaeologists. When we work in Turkey, we work with experts of the sites, and the same in South America. And this is really important because we try to have all the available information for that site. So, of course, this means that we can have also the situation that the satellite does not show anything, but we cannot say that nothing is violent, because it depends on the moisture, humidity, and so on. And so this, of course, is... but we try to integrate, just because it's the only way to be sure that we try to consider and to have the best for each site. And the second question was... I forgot about the second question, sorry.
Sorry, that's okay. Well, the second question was about reconstructing the data. If you have it's part of the big object, but you have only pieces, do you employ any tools or techniques to reconstruct it yet?
Again, it depends on the project, because, for example, in the case of Pachacamac, we work with a team which is there the whole year, because it's a museum, is very important. So they are very motivated in reconstruct, let me say, not reconstruct, but have all information available and to excavate as much as possible. In other cases, as for example, in ICCSA, actually is a private, is not easy to go there to have some investigation. So for that size, the maximum we can have is the virtual reconstruction and also the virtual, excavation. But in this case, it's very important the knowledge, because we can have some danger, so we have information rating the landslide. So from this point of view, the most important information is to know that the site is there and to check from time to time, for example, the landslide. Also because it's not easy. The excavation are really costly, and after the excavation you need additional money, because otherwise it's not easy the management of the site. Thank you for the question.
Thank you very much. Thank you for everybody to attend this plenary session, and now directly we have to go to the parallel session in 2 minutes. Thank you again.
Ah, okay, no. So,